Hello, I am Goy Xiang, which is the leader for this database project group. So my name is Goy Xiang, and here are my the teammates, which is Mark Jungyang, Tan Jun Kwan, Liu Shangnan, and Tian Wei Sheng. So today we will be demonstrating basically our database project, which is the SQL statement. But before that, we will give some introduction about our project. So in this project, uh, we are basically making basically our client is a local restaurant which is located in Arkansas, which is called Sdap Kitchen. So currently, our client performs all of their daily operation manually, such as order taking and managing sales, and also managing their inventory. So we feels that doing manual work for all these three things is unnecessary work and can cause some data redundancy and also data loss. So that's why we propose to make a database-driven management system that will simplify their daily operation. We and also allow them to basically manage their data for their operation basically. So our proposed database system is called Sdap Kitchen Management System. Actually is a database system using relational database. And so throughout the project, we have designed the conceptual ERD for it through the business rule. And then from the business rule and conceptual ERD, we created the logical ERD, which is basically a logical ERD that can be implemented into a actual database. So from there, so for the logical ERD, we have the updated data dictionary, and also we have done normalization for all the relation to ensure that each relation had at least achieve the BCNF, which is Boyce Court Normalized Form. So for each relation, we go through the four stages, which is from first normal form to second normal form, third normal form, and then lastly the Boyce Court normal form. So with all the normalization done, we have basically we get the logical TRD, and then we can then make it into the make it into an actual SQL statement for it. So I will pass to the one in charge for creating the database and the relation to explain about the SQL statement for it.
So next is our SQL demo. So first we need to create the database first. So this is create a database for Sdap Kitchen. Next we use the Sdap Kitchen Management System. So next we do the table user create the table user. Next create the customer. Next create the order tracking working. And next I created the inventory manager and store the manager and create the table menu and create the table order. And next is create order making. And next is called the create the table view. And next the shelf view. And next the create the inventory. Next the menu ingredient. And the next last is create the table. So I show the table. So this is based on our schema. So this is our create the table in the Sdap Kitchen Management System.
Over here, right, we have quite a few tables that after we created, we will need to insert data into them. And to start off, we will have insert into user. We will have a few values insert into it. And then I will have this line to select all of the uh, data from
Yeah,
user table. Yeah. And then next is we also have a insert into the customer table. And also apart from that, we also have inserting data into the order taking workers. And to do that, we need to add more values into the user table, which is the W0001 to 5. And then when we insert the values into the order taking workers, we will use the corresponding W001 to 5 as the primary key, but it will also be the foreign key from the user table. And we will repeat the same logic for the rest of the tables, namely the inventory manager table and also the store manager table. So this is all of the tables, and I will try to run it now. So you can see here, this is the user table, and then this is the customer table. This is the order taking worker. This is the inventory manager. And then lastly, we have the store manager. So that
Can
is all.
you
Yeah,
can you add another uh, statement at the end for select all from user?
all from user. Okay. Then as you can see here, this is the full one that because after we add all of the new primary keys into user so that we can add into the corresponding inventory manager, order taking worker, and also storage manager, it will also update back into the user table to look like this. So it will start from some of them only to having a lot more. So that's all for my part.
So from here we can see the M001 until 5 is the primary key of the new relation, and there's adding 4 after that, and the next one is insert into order relation. Start from 0001 until 7 is the primary key of this table, and then is the order making table, insert into order making table, and the OM 0001 until 7 is the primary key of this table, and then is the insert into bill relation based on the order records. You can see the info here, and the B001 until 7 is the primary key of this table, and then is sales bill insert into sales bill relation, which for checking sales based on bill, and insert data into inventory relation. The I001 until 10 is the primary key, and then is the menu ingredient, insert into menu ingredient relation, and the last one is the insert into restock. So now I would like to run this code. So as you can see here, the quantity of the inventory already changed. So now I'll pass to the next team member to present.
Okay, so for now, I would like to present about the query part. So which has the select and also the update comment. So first let's look at the first query. So first is about the query for all users. So it's just simply write select all from user. So if we run for this code, so it will come up all the data from the user relation. And then let's try to run another code, like query for customer with related data from user. So this time we also write like data from customer and also join another relation, which is the user, by using the user ID. So when we run this SQL code, and the relation will be like this. We got the user ID and also the data which are from different relation. And then we try to run another query, which is query from store manager with related data from user and with some condition, which is as manager in store will be equal to true. So it will be set off from store manager and join user using user ID, and where the condition is the as manager in store will be equal to true. So let's look the result. The result will be like this. So we have as manager is not true, which is 1. So it will come out with the data like this. And next is about the query for orders with condition, which is we can add more we can add more with one condition, which is order status. It can be equal to preparing, and also user ID can equal to some ID like W0001. So the code will be set off from orders where order status equal to preparing and user ID equal to W001. So the table we got all the order status in preparing and all the user ID in this ID. So the result will be like this. And then it's about the update. So mm, so we have the update about the orders when the order is done and update the inventory accordingly with the ingredients used. So let's check it one by one. So we can see that there's a update orders, and then we'll set the order status equal to done, where the order ID will be this ID, which is 0001, 00002, 00003. So we run this code to update the data. So it haven't come out anything because we just update only. So this update when the order is done, and then we update for the inventory when the ingredients is used for the order, and then you can see that there's update inventory, and then we will use join, and then prepare set the inventory ID from the menu ingredient relation, and then we'll use sum to use the order quantity from the orders relation to multiply the ingredient quantity from the menu ingredient relation. So this result will be stored in another temporary relation like total use. So this data will come from the orders relation. So we'll also use the menu ingredients, and then also on orders and also the on menu ID from the orders relation will be equal to the menu ID from the menu ingredient relation. So the condition will be the order status from the orders will be equal to done. And this will be grouped by the inventory ID from the menu ingredient. So same as the relation will be the usage table, and then on the inventory ID from the inventory will be equal to inventory ID from the usage table like the previous one. And then the inventory quantity from the inventory relation will be set equal to the inventory quantity from the inventory minus with the total use from the usage table. So we just simply update for this. Okay, and then let's check for the let's check for the inventory relation. So this is the relation that uh that that the data is already come up with when the orders is used the ingredient for the menus. Okay, so let's look the next one. Sorry. Okay. So here we also have some query for the orders with condition like the order status is done. So we just run it. So the relation will come up with like this, which is the order status all will come up with done. And then we have the query for bill with condition payment status will become not pay. We run this. So the payment status all will be not paid. Payment method will be not because the customer will haven't paid for their order yet. So and next is about the update bill when the customer has paid the bill. So we run this code to update the bill, and then we have the query for the bill with condition that payment method is equal to credit or the debit. So we try run. So we have all the credit and debit in this relation. And then we have also the query for sales data viewed by the store manager, which is SM001 for this date. So we just simply run this code. So you can see that we have the store manager with this ID, and the sales will be like this. So this sales is from this date, so it is currently. And then we have the query for inventory to check the inventory items. So it's just show all the data from the inventory relation, just like this. So you can see that the last query will be query for inventory to check inventory items with quantity less than 30. So in this relation, we'll also need to see that the inventory quantity will only come up with less than 30. So this is all the query for the system. So I'll pass the delete comment from for other teammates.
So basically, I have run basically the same code as my teammates have run. So now we'll just be doing for the deleting part. So in our database system, we will have delete for 3 relations, which is for orders, for menu, and for inventory. And also since in our relational schema, we have put delete on cascade for most of the foreign keys. So that means that like for orders, if I delete the one specific order, they will also delete basically the records that point to point to the order, the records that got deleted in the orders. So for now, I will select all from orders to see what's the data that is in the order relation currently. So we can see that there's 7 order inside the order relation. So I will now run the SQL statement for deleting. I will delete the last order, which is 0007. So I will delete these 4 records, and I will delete it. And now when I select it again, it will shows that the order is deleted. So basically, that's how we will delete the order for the record of order of one of the record of orders from the relation. And then next we'll look at for menu. So currently we have 5 menus. So this time I want to delete the last menu also. So I will delete the IST. So I will just use delete for menu and identify by the primary key, which is M005. So I will delete this and select from menu. And now it will show that the menu only have 4 left. And since we using delete for cascade, just now there's actually a few orders that actually relate to the last menu, which is the ICT menu. So if I select from orders again, it will also delete all the menus that all the orders that point basically ordering the ice cream menu basically. So now only we have only 5 left, 5 orders left. So one of the order is deleted automatically when I delete the ice cream menu. And then next is for inventory. So inside inventory, uh, from when we start and inserting the inventory, we insert 10 basically 10 ingredients that will store inside the inventory. But inside throughout the updating and basically with the menu, we actually didn't use the last ingredient, which is the tofu. So right now we can, if didn't use it, basically it means that the business basically Sdap Kitchen can basically stop supplying for tofu. So if they want to stop supplying for tofu, they can just delete the record for it, which is by using this statement, and it will automatically delete it. And yeah, so now we only have the remaining 9 inventory item that will be used in our system lah. So that's basically what we have for the deleting for our database. Basically the deleting for the Sdap Kitchen Management System will have these 3 main deleting function lah. So I think that's all for me to explain about the deleting function. I think that's all we will be demonstrating for our database system. So I think we can. Is that all? What else should we say?
Well, thank you for listening to our
Yeah, thank you.
demonstration. Even though very long.
So thank you for anyone watching this video, for watching our demonstration of our database system, and I hope that our database system will be useful for our client and somehow help them in their business. So that's all.